All right. Here are the notes over inverse functions. So this is standard 15 here. Now, if you don't have a copy of the note sheet to fill out, stop the video now, go to the menu, and there's a link there to the notes. Or if you're in class, go ahead and just grab a copy from me. Okay, 5 important things to know. Let's start that here. Let's get rid of this recording button. Okay, inverse functions undo each other. Super important. Now, this might come up a little bit later in the video, but I want to make this point a couple times because it was not clear in the annotated notes. So I want to make sure that you're getting it from the video notes. Even if a function is not one-to-one, it still has an inverse. The inverse might be not a function, but even if a function is not one-to-one, even if a function does not pass the horizontal line test, it still has an inverse. It just does not have an inverse function. It has an inverse, but its inverse might not be a function. Okay, more on that later. But for right now, inverse functions undo each other. So, for example, here's our function. We talked about functions like a machine here. Let's say this machine does add 3. Whatever you spit into it, you add 3 to it. So this function, if your input is 10, the machine goes ahead and adds 3, and the output is 13. So what is the inverse of this? What is the function that undoes adding 3? Well, right here, that's the function that subtracts 3. So you can see right here we've got this little example. So we plug 1 into our plus 3 function, our add 3 function, our add 3 machine, if you want to think of it that way. It spits out 4, and I want to do the inverse, so I'm going to undo that. I subtract 3 to get 1. And so this is the main idea about functions. Let's say we start with 7. Let's do a function that multiplies by 2. Plug it into the machine. This cool guy with his nice overcoat pulls the lever. Boom, it multiplies by 2. It spits out 14. Now, his brother here, who faces the other way, he's going to run the inverse machine. What's the inverse machine going to do here? Well, it's going to divide by 2 to get back to 7. How about if we start with 5? Let's use a different machine here. Let's say our machine squares it. So 5 gets squared, we get 25. Our inverse machine, what's it going to do? It's going to take the square root to get 5. Okay, so functions and their inverses undo each other. All right, so if we've got f of x equals x plus 3 and g of x equals x minus 3 are two inverse functions, let's look at a t-chart, which is another way to just say let's look at some inputs and outputs. So we've got some inputs here for f of x and for f of x here. So we've got -2. We plug it in to the function. -2 plus 3 is 1. And we go ahead and continue plugging in these inputs to get our outputs here. Okay, now a lot of these notes, it'd be a good idea to have the video notes and to write on the back of them. The back of the video notes, you could be writing a lot of these things. Okay, so that is what our f of x function looks like. So let's take the output of f of x. So that's here in this column. These are the outputs, the y values. F of x means output or y. And plug it in to g of x as an input. So that's the composition of functions thing that we did. Yes, not yesterday, but we did composition of functions. So what we're doing is we're doing g of f of x. We're taking f of x first and finding that, and then taking our answer we get for f of x and plugging it into g. So let's take our outputs here and plug it into g. So I'm taking all my outputs here. So first I'm going to take 1 and plug it into g now. Since that was my first output of f of x, I plug it into g, and I get 1 minus 3 gives me -2. Take my next output from f of x, 2, and make that my new input of g of x, plug it in, 2 minus 3, I get -1. And so on and so forth. I plug all my outputs from f of x into g of x, and look at what happens. Compare what happened, what we started with, to what we ended with. The function f of x took our original inputs to some values, 1, 2, 3, 4, 5, And then g of x took those values, 1, 2, 3, 4, 5, right back to what we started with. -2, that's what we started with here. -1 went to -1. 0 went to 0. 1 went to 1. 2 went to 2. Fantastic. All right. So if the point 5, 8 was on the original function, what pair would be on the inverse? So remember, if this over here, f of x, was our original function, if we had 5, 8 here, what pair would we have over here on the inverse as an input, then output? Well, we would have an input of 8 getting us back to 5. So we would have 8, 5. 8, 5 here. Okay, so that leads us to our second key point. Inverse functions switch x and y. Now, like I said, these video notes, there's a lot of notes in here that you need to take on your own. There's space on your paper to write the 5 key things to know, but you need to kind of write the in-between stuff on the back. So make sure you're doing that as you go along. Inverse functions switch x and y. So if x comma y is a point on our original, y comma x is a point on our inverse. Timeout. Function notation. The inverse of f of x is written like this. F and then -1 with a power, it looks like a power at least, of x. You read this as f inverse of x. Okay, now this -1 does not act like a power. In other problems, whenever you see something raised to the negative first power, it means that you want to move that thing to the denominator. Here, it's simply notation. F -1 just means f inverse of x. Don't think of this -1 as a power like any other power. It's just the way you write inverse in function notation. All right, back to our normal notes here. Okay, given this t-chart for some randomly made up f of x, this is on the front of your notes. You can follow along with me. It's right below the box, sort of in the middle-ish of the page. Given this t-chart, find the t-chart for f inverse of x. So if you know the inputs and outputs for f of x, go ahead and see if you can fill in the inputs and outputs for f inverse. This is a great time for you to pause the video, do it on your own, and then unpause and check the answer when you get back. All right, now we're back. Here are the answers. What we did is we just switched the x and y coordinates on the inverse. So if -5, 0 is on the original, 0, -5 is on the inverse. So on and so forth through all of these different points on the original, give us a point on the inverse. Okie dokie. I wonder what they look like when they're graphed. So this is right next to that on the front of your notes. You can follow along with me. So this is a graph of f of x. On here, let's graph f inverse of x. So in a color other than black, since the points on your notes are already in black, go ahead, find a marker, colored pencil, something, and graph all the points of f inverse of x on that graph you already have. Go ahead, pause the video and do that and see if you can figure out what's going on. When you come back, we'll talk about it. All right, here we are. This here now in blue is f inverse of x. Do you see kind of a pattern? Red is f of x, blue is f inverse of x. Is it kind of any sort of pattern here? Anything that relates like the blue points and the red points? Look here, 2 red points, 2 blue points. A blue point, a red point. A red, and this one right here has a red and a blue. I know it's hard to see, but there's a red outline there. And then there's a blue and a blue. A red and a blue. So what's going on here? So maybe you don't think it's too exciting yet, but if I add in a line right here, now look at it. Look at what happened to the red points. How do you get from the red points to the blue points? You reflect over this line. So this red point ended up, boom, over here at this blue point. This red point on f of x ended up, boom, over here on the inverse. This red point from the original ended up here on the inverse. This red point that was right here, when I look at the inverse, ends up right where it's at. Pretty freaking awesome. That's what that dog thinks, at least. What line is that with a y-intercept of 0 and a slope of 1? y equals what? Y equals x. The original and the inverse graphs are symmetric across y equals x. They're reflected across y equals x. That's our point number 3 in the 5 things to know about inverse functions. Or inverses at all, not even just functions, because some inverses aren't functions. Remember, some inverses aren't functions. You can still find an inverse even if it ends up not being a function. All right, what if we wanted to know if two functions are inverses without graphing? So let's go back to our trusty f of x equals x plus 3 and g of x equals x minus 3. So when we compose these two functions, f of g of x, this goes back to standard whatever, who knows, I don't remember off the top of my head, where we did composition of functions. So we rewrite f and leave space there wherever there's an x, and we plug in g of x. So I'm going to plug in x minus 3 there, and then x minus 3 plus 3, I get x. So f of g of x is x. So when I plug x into g and then plug that into f, I just get back to x. That makes a lot of sense. Inverse. These two are inverses, so they undo each other, and we're left with just x as our final answer. All right, let's try it the other way around. What about g of f of x? So I rewrite g, which is x minus 3, leave space there to plug in f of x. Then I go ahead and plug in f of x, which is x plus 3. Then simplify this, x plus 3 minus 3 gives me just x. So g and f undo each other here, and g of f of x just gets me back to x. So this makes sense. Inverses undo each other. We should always get back to x if these two functions really are inverse functions. So if f of g of x equals x and g of f of x equals x, so that means if we do it in both orders and we get back to x either way, then f and g are inverse functions. Okay, fantastic. We got 4 things down. Let's keep going. Are these two inverse functions? This is where you try it and then you check back and you see the answer. So pause the video now, try this on your own, and then come back and we'll go through the answer together. All right, now we're back. Let's try it together. We got to check 2 things to check if these are inverse functions. First of all, let's check f of g of x. So I've got to rewrite f of x, that's x squared plus 2, and leave space here to plug g of x in for the x. So the square root of x plus 2 goes in for the x in f of x. Now square root squared, these 2 things cancel each other out, undo each other here. So we're left with just x plus 2 plus 2. So we're left with x plus 4 for f of g of x. So we didn't get back to x. So no, we right away know that these are not inverses because both f of g of x and g of f of x have to give us just x. Let's go on to the second one now. This is the time. You pause the video, come back when you're done, and we will go through it together. All right, here we go. Let's try f of g of x first again. So we rewrite f, that's 3 times x plus 1, and we leave space there where the x is so we can plug in g of x. 3 times x plus, or x minus 1 over 3, that all gets plugged in there, then plus 1. Now this 3 here, remember when we multiply fractions, we should think of this 3 as a 3 over 1. If you've done some standard 1 reassessing recently, you'll realize that this 3 and this 3 down here are going to make a 1. So we're just going to be left with x minus 1 plus 1. And then minus 1 plus 1 gives us just x. Okay, f of g of x worked. Not enough to stop there. We also have to check g of f of x. So rewrite g, x minus 1 over 3. And we're going to plug f of x in there in place of x. So I plugged 3x plus 1 in place of x right there. Now on the top, I've got my plus 1 minus 1. That becomes 0. So I've just got 3x over 3, and the 3 over 3 becomes a 1, so I'm just left with x. So we see that, yes, these two functions are inverses. Fantastic. Okay, last item, how to find an inverse. What if I have a function and I want to find its inverse? All right, here's an example. F of x equals 2x minus 10. First step, replace f of x with y. Rewrite your function as y equals 2x minus 10. You could get away with skipping this step as long as instead of doing switching y and x, you switched f of x and x. But you could always just make it y equals so that you could switch y and x. Because remember, f of x and y, they mean the same thing. So once we replaced f of x with y here, now remember rule number 2 up at the top, your 5 things to know. We switch y and x. So we end up with x equals 2y minus 10. Okay, now finally, all we have to do is solve for y. We just have to solve for y. And to solve for something means to get what that thing equals. So we got to get the y by itself. So we have y equals. So let's get rid of everything else that's on that side with y. So we add the 10 to both sides. Then we have x plus 10 equals 2y. Then we divide both sides by 2 because we want to get what y equals. That's solving for y. And we get x over 2 plus 5. Y equals x over 2 plus 5. So this is the inverse of the original. So we replace y with f inverse of x so that we can see that our original function here was f of x. Our new function here is f inverse of x. F inverse of x equals x over 2 plus 5. Okie dokie. That was number 3 down at the bottom of your notes if you didn't manage to catch that. Let's check out these graphs of these two functions. Remember what the graphs of the inverses were supposed to look like? How they were reflected over the line y equals x? In blue there is the line, in blue is the line x over 2 plus 5. X over 2 plus 5 is right here because there's the plus 5 for the y-intercept and a slope of 1/2. In red here is the other line, the 2x minus 10 with an intercept down here at negative 10 and up to over 1. Look at how they're so nicely reflected over this line, y equals x. So if you ever have a graph here and you want to figure out the inverse, you've just got to reflect things over this line, y equals x. All right, so that gives us number 5. To find the inverse, switch x and y and solve for y. Okay, to find the inverse, that's if we have an equation for a function and we want to find its inverse, switch x and y and solve for y. All right, this is another example down at the bottom. Good time to pause your notes, pause this video, try it on your own. When you come back, we'll do it together. All right, here we go. Let's check it out. First, rewrite it, replacing y for f of x. Next, switch x and y. Now we have to solve for y, so I'm going to subtract 3 first. So I have x minus 3 equals y squared. And then how do I undo the squared? I have to take the square root of both sides. So y equals, and now this is something right here that we haven't talked about yet. So definitely important to note this down. When you're solving an equation, and as part of the process, you take the square root of both sides, you need to add in a plus or minus because the square root could either be positive or negative. So it could either be the positive square root of x minus 3 or the negative square root of x minus 3. So whenever you're solving an equation, this might be a good thing to make a note of. Whenever you're solving an equation and you take the square root of both sides, you need to add in a plus or minus. Okay, so f inverse of x equals positive square root of x minus 3 or negative square root of x minus 3. So right here, this is our original, x squared plus 3. And then right here, look at where my mouse is right now. Follow my mouse as I go from here to here. This is positive square root of x minus 3. And then from here to here, this is negative square root of x minus 3. If you remember back to what we just did, the negative out front would just flip it over the x-axis. So positive square root of x minus 3 right here just gets flipped over here to get negative square root of x minus 3. The reason we split those up into two separate things is because if we put them together like this, like the whole blue graph, it is not a function. Look, it does not pass the vertical line test. This input right here at 1, 2, 3, 4, 5 has two outputs up here and down here. So it's two different equations here, two different functions here make up this inverse. The whole inverse is this whole thing, but if we want to talk about it as functions, we've got to split it into two separate functions. Positive square root of x minus 3 and negative square root of x minus 3. All right, let's look at the next one. Great time to pause your notes, and when you come back, we'll go through the answer. All right, here we go. So we've already got y in there, so we just switch x and y. X equals square root of 3y. We want to undo the square root, so we've got to square both sides. So x squared equals 3y now, and then we just divide by 3. So y equals x squared over 3. So that's our inverse. Let's go right on to the next one. F of x equals 3x squared minus 2. Pause the video now, try it on your own. When you come back, we'll go through the answer. All right, gonna go through the answer. Replace f of x with y. Y equals 3x squared minus 2. Now we're nope, I'm one step ahead of myself. Hopefully you realize we still need to switch x and y. Fantastic, we switch x and y there. And now we need to solve for y. So first thing I'm gonna do is get rid of this hanging off plus 2 by adding 2 to both sides. X plus 2 equals 3y squared. Now, just the y is being squared. So I don't want to square root yet because I'd have to square root the whole side. I want to get rid of this times 3 here. So I'm going to divide both sides by 3. So I've got x over 3 plus 2 over 3 equals y squared. Now I'm going to square root. And if you remembered what we talked about, I don't know, 5 minutes ago, when I square root both sides when I'm solving an equation here, I need to add in my plus or minus because I'm going to have two answers there, the positive one and the negative one. So there, f inverse of x equals positive or negative square root of x over 3 plus 2 over 3. All right, here's once again the list of those 5 key things to know about inverse functions. If you need to copy any of those down, you can pause the video and do that. Okay, that's the end. Hope these notes were helpful for you. Now go ahead and do some practicing.